Hello everyone. Welcome to the video lectures. I'm Professor Mayur Gohil. I'm taking up the following question which says to find the two non-singular matrices P and Q such that PAQ is in the normal form where A is this matrix. Now let us see how to go about this question. This question was asked in one of the examinations of MU for 6 marks. So let us see how to go this about it. Now first of all, note over here that the matrix here A is of the order 3 rows and 4 columns. So we can note down this fact. Now very important thing is that whenever you have a PAQ form question, you must write this statement compulsorily, that is, let A with the order 3 cross 4 is equal to I, the identity matrix of order 3 rows 3 A, again the matrix A, then which is 3 cross 4, if you want to write that is okay, and here you must write I 4 cross 4. Now how do we write this? This is very important. See, whatever is the order of the matrix, okay, the number of rows of the matrix, okay, that is where the first identity matrix can be made of. So that first, whatever is the number of rows of the given matrix, that much is the order of the identity matrix that will be placed on the left of the matrix over here. Okay, so this is here. Now here, the next thing, the number of columns in the matrix is deciding the order of the identity matrix on the right side. Okay, now you can see, because of this reason, and also there is one more thing that we already now know by this time, that when we now perform all the row operations, the row operations will be performed on the matrix, this matrix, okay, row operations or row transformations, and the column ones will be operated on this one. Okay, so you have to be very careful regarding this in the following question. So now let us do this quickly. So what do we do on the right hand side? On the left hand side, first we write the matrix, then you have the identity matrix, then there is A. You don't write this matrix again, you keep it as it is. Then there is I 4 cross 4. So you set up this in the answer properly, and then begins the next important step. Now one very caution important thing is there, that in some books there is a substandard notation used, that is, they write a 3 cross 4 and then they write I3 a I4. I request you not to use this kind of notations. These are very very substandard notations. They sometimes, it is okay, but I still prefer not to use it because it is a substandard notation, that's it. So I avoid using this notation. I prefer to write it clearly, so there is no room of any ambiguity left out. Okay, so we don't leave any room for doubt for anyone. So yeah, now we perform the row transformation. So perform the first element over here is 1 in the LHS. Okay, we want to make this matrix on the LHS as the normal form. So what we need to do is, on the diagonal element we have to make it 1, and we rather we have to make an identity element in the top leftmost corner of the matrix. So what we will do is, we will perform R2 changing to R2 minus 2R1, and R3 changing to R3 minus 3R1. Okay, this is the transformation that we are going to do. So do it systematically, then you will get a systematic answer in a least number of steps. Otherwise you can go on and on and on, and you will get somewhere through. Okay, now the calculation comes into the picture. So let us do the calculations. I'll do the calculations in the corner. So here it is 1 minus 2 times 2, so it is minus of 3, so this is minus of 3. Then next will be here you have 4 minus 2 times 3, so that is minus 2. Okay, then there is 3 times 3 minus 2 times 4, that is 3 minus 8, that is minus of 5. Okay, so there is minus of 5. So we have that. Now we go for the next one. Here we will have 0. Okay, so 0 minus 3 times 2, that is minus of 6. So for that we will have minus of 6 here. The next one is 5 minus 3 times 3, so 5 minus 9 is minus of 4, so here it is minus 4. And then there is minus of 10 minus 3 times 4, so then there is minus of 22. Okay, we have that. Now we go for the next part. On the RHS, what we have to do here, the first row will remain the same, but the second row and the third row, the following changes will be noticed. That is, here you will have minus 2, okay, 1 0, and in the third row you will have minus 3 0 1. Okay, so this is the thing that we will have. And the fourth, this matrix that you see, the 4 cross 4 matrix, that remains unchanged. Now we go for the next transformation. The next is pretty much straightforward and very quickly you can do this. You can do is column 2 changing to column 2 minus 2 times column 1, column 3 changing to column 3 minus 3 times column 1, and then column 4 changing to column 4 minus 4 times column 1. Now when you perform this, what will happen on the LHS, let us see. So let me erase off these terms. So 1 0 0, and now all these entries in the first row other than A11 will become 0. Okay, and the other elements will remain unchanged. Okay? And the first matrix on the RHS will also remain unchanged, and here will be the change now. So the change will be observable here like this. So it will be, so the first column rather has no change. The change all will be seen in the first row itself now. So here when you do minus C2 changing to C2 minus 2 C1, so here it will be minus 2, here it will be minus 3, because C3 is changing to C3 minus 3 C1, and then C4 is changing to C4 minus 4 C1, so there is minus 4. So that's all what you will have there, and all other entries will remain the way they are. Okay, so this is how it works. Now we will perform here R3 changing to R3 minus 2R2, right? 1 0 0 0 0 minus 3 minus 2 minus 5, and here I get 0. Now what I do is minus 6. Okay, so minus 6, and there is minus over there, right? So let us do the rough work calculation here a bit. So minus 6 minus 2 of minus 3, so that is 0. So this is 0. Then there is minus 4 minus 2 of minus 2, that is again 0. Okay, these all are zeros. So this is 0. Now I have another element here. It is minus 22 minus 22 minus 2 times minus of 5, that is minus 22 plus 10, that is minus of 12. So I get minus 12 over here. Okay, so this is the matrix that gets the answer there. Now the next part is here. Here starts a bit of calculation. 1 0 0. Now third row minus 2 times the second row. Okay, so what we do is second row remains unchanged. I'll do the calculation for the third row. So it is minus 3 minus 2 times the second row, so minus 2. So that is minus 3 plus 4, that is 1. So that is 1. Okay, 0 minus 2 times 1 is minus 2. Here it is 1. So this is the matrix that gets generated, and the column matrix on which all the column operations are happening, that matrix will remain unchanged. Okay, now there is a easy way out to handle this situation, so let me tell you how to handle it. See, what is our goal is that we want to establish a identity matrix on the top left corner of the matrix. Okay, so I want this element to become 1. Somehow I want to make it 1. So let me do that, and I can do it very easily. Now I can perform directly the following operations. Perform C2 changing to C2 divided by minus 3, and C3 changing to C3 divided by minus 2, right? That's what I can do easily. So what I get in the terms of matrix is 1 0 0 0 1 0 0 1 0 0 minus 5 minus 12, right? And the this matrix remains unchanged, A, and then here I will have 1 0 0 0. Now C2 is divided by minus 3, so I will have 2 by 3 minus 1 by 3 0 0. Then here it is C3 is divided by minus 2, so I'll have 3 by 2 0 1 0, and then it is C4, there is no change, right? So I'll just keep minus 4 0 0 1. Okay, now we have another operations to be performed, that is using the second A22 element, we make all other elements in this row 0. So which all elements we need to make 0 is this one and this one. We make them 0. So how can we do that? Let us perform that. So we now write perform C3 changing to C3 minus C2 and C4 changing to C4 plus 5 times C2. This can be done. And now let us see what do we get. So our matrix will become 1 0 0 0 1 0 0 0 0. Here we will have 0 0, and here there will be minus of 12. Okay, and here no change in this matrix because it is related to the row transformations. So I will have the change will happen in the matrix where columns are involved. So column transformations are involved rather. So we will now have the following change in the third column and the fourth column. So these two columns are unaltered, no changes. Now we have 3 by 2 minus, right? So the element was 3 by 2 minus, we have to do C2. So C2 is 2 by 3. So that is going to be 6. 9 minus 4, so that is 5 by 6. So here the first element will become 5 by 6. Then here we will have 0 minus of minus 1 by 3. Oh, we had minus 1 by 3 here. So here it will be 1 by 3. And then here there is 1 and here there is 0. No change. After that we have here minus 4. Okay. And for minus 4 in the fourth column it will be plus 5 times C2. C2 element is 2 by 3. So it will be minus of 12 plus 10 by 3 is minus of 2 by 3. So this element will be minus 2 by 3. And then here there is 0 plus 5 times C2, that is minus of 1 by 3. So that is minus of 5 by 3. Here it is 0, here it is 1. This is the answer that we would get. Now we want identity matrix in the top left corner, but I still see that there is minus 12 there, though we have got a 2 cross 2 identity, but it is not complete because there is minus 12. So what I will do, the last operation here is the most easiest operation. I can either do row or column, doesn't matter. Now I am going to perform, I'll perform the row because column has already gone a little bit complicated. So I'll perform R3 changing to R3 divided by minus of 12. Okay, so minus of 12, we will do the division and we will get there is 1 0 0 0 0 1 0 0 0 0 0 1, and here we get is 1 0 0 minus 2 1 0, and here it will be minus 1 by 12, and now we divided there by minus 1 by 12, so it will be 1 by 6, and here it is minus of 1 by 12, and Here it is the same matrix. Now what we need is we need to interchange the column. So we perform C3 interchange with C4. Now I would like to tell you one very important thing. In some very substandard notation is used, some books or some people use very substandard notation, something like C34. It looks so much wrong. It is talking about 34th row or 34th column. I don't suggest anybody to use this kind of notation because it does not say whether what is happening there. So, some books use this kind of notations. Please do not use this substandard notations. Please do use standard notations. And so now when you use your this column transformation, the column transformation gives me 0 0 1 0 0 0, and no change in the first matrix here. Here it is A, and here it will be 1 0 0 0, 2 by 3 minus 1 by 3 0 0. Here it will be minus 2 by 3 minus 5 by 3 0 1, 5 by 6, 1 by 3, 1 and 0. Okay, so here after this writing this much, a student is expected to write the following thing also. Then you write here the matrix in the LHS is the required normal form of matrix A, and RHS is the PAQ form where P is equal to P matrix is this first matrix. So 1 minus 2 minus 1 by 12, 0 1 1 by 6, 0 0 minus 1 by 12, and Q is 1 0 0 0, 2 by 3 minus 1 by 3, 0 0 minus 2 by 3 minus 5 by 3, 0 1, 5 by 6, 1 by 3, 1 and 0. This is Q. So once you are done, this is how you get your full 8 marks or 6 marks, whatever are the marks allocated. So this was for 6 marks. So I hope you have followed this procedure. Now you can see that there is the identity matrix established in the top left corner of the matrix. Okay, so this is the identity that you can see here. So this is what is required. Okay, I'll just put a highlighter, that would be good. So I'll highlight this here, that this is the identity. Okay, you can see this is the identity matrix that you wanted. So, and this is the normal form, rather the entire matrix is in the normal form. So I hope you have followed the entire example. Please hit like button, your feedbacks in the comment section, and I would be happy to help you.